Hi, in this video, I want to go over chapter 6 of elementary statistics in OpenStax. Chapter 6 is talking about the normal distributions. We learned in chapter 4 about the discrete probability distributions, and in chapter 5, we started the continuous probability distribution, and we explained the uniform distribution, which is one type of a continuous probability distribution. Now in this chapter, we want to talk about the normal distribution. Normal distribution is also one type of the continuous probability distribution. When do we have a normal distribution? When we have a symmetric bell-shaped curve, we can call it a normal distribution. And we usually show a normal distribution by letter N. And if you remember, we showed the uniform distribution by U. But for the normal distribution, we use N, which represent the normal distribution, and inside the parenthesis, we put mu and sigma. The mu is the mean, and the sigma is the standard deviation. So which means for every normal distribution, we need the mean and the standard deviation. And x is our random variable. So every random variable that can be represented as the n of mu and sigma, that's a normal distribution. And all normal distributions are usually a bell-shaped curve, a symmetric bell-shaped curve, which the mean is always in the middle of the curve. One specific type of normal distribution, which is called the standard normal distribution, is a normal distribution which the mean is always 0 and the standard deviation is always equal to 1. So if we have a normal distribution which the mean is 0 and the standard deviation is 1, that means we have a standard normal distribution. In a standard normal distribution, we don't have x as a random variable. We have z values. So a standard normal distribution will be represented as z values. And if you look at this picture, in any normal distribution, we always have x values on the horizontal number line. But when we have a standard normal distribution, we have z values on the horizontal number line. And since the mean is 0, that means the center of this bell-shaped curve is 0. And the standard deviation is 1. That means we just keep adding by 1 to the right and keep subtracting by 1 when we go to the left. Now the question is how we can transform x to z or z to x. If we have a problem which the x or the random variable is given to us, but we need to convert it to z, we are going to use this formula. So we say the z is always equal to x minus mu divided by the standard deviation. And using this formula helps us to convert z to x or x to z. It depends which one is given and which one we need to find. And something that we don't have to forget, in every probability, every continuous probability distribution, the area under the curve is always equal to 1. And that applies for the standard normal distribution as well. Let's look at the first example. It says, what's the z-score of x when x is equal to 1 and x is a random variable in the normal distribution, which the mean is 10 and the standard deviation is 3. Okay, so the mean is given to us, the mu is given, the standard deviation or sigma is given to us, and we have the x, and we want to find the z. Okay, how do we convert x to z? By just using the formula, x minus mu over sigma. And x is 1 minus mu is 10 over sigma, which is 3. And 1 minus 10 is negative 9. Negative 9 divided by 3 is just negative 3. So the z-score is negative 3 in this case. Next example. It says the mean height of 15 to 18-year-old males from 2009 to N was 170 centimeters with a standard deviation of 6.28 centimeters. Male heights are known to follow a normal distribution. When the problem gives me this, that means I can use everything that I learned about normal distribution and I can apply all of those formula and all of the rules. And it says let X, or the random variable, is the height of a 15 to 18-year-old male in 2009 to 2010. Okay, since we have a normal distribution, how do we can show the normal distribution? The X is a random variable and we have a normal distribution, which the mean is 170 and the standard deviation is 6.28. So we put these two values inside the parenthesis to represent the distribution. And don't forget, we always put mean first and the standard deviation second. Now it says, suppose a 15 to 18-year-old male was 168 centimeter tall. Find the z-score when x is 168. Okay, so the x is given to you, you want to find the z. Just use the formula. And the formula tells me every z value is x minus mu over sigma. If x is 168, if mu is 170, and sigma is 6.28, what do we get for z? Which is negative 0.30. Now it says this z-score tells you that 168 is how many standard deviation? Something that's important here, that every z value gives you the number of standard deviation. If you remember when we talked about the standard normal distribution, we said that the mean is 0 and the standard deviation is 1. And the numbers on the number line are z values. So z values are the number of a standard deviation. When that shows us that number is on the right of the mean or on the left of the mean based on if its z value is positive or negative. If z value is negative, that means it's on this side. And this side is on the left side of the mean. So we know that 168 is to the left of the mean. But how many standard deviation to the left? It's 0.32. Less than 1 standard deviation. It's 0.32 standard deviation to the left of the mean. Next part says suppose that the height of a 15 to 18-year-old male has a z-score of 1.27. In this part, the z is given to you and it says what's the male's height? Male's height means the x. So it's asking you to find the x. Okay, so in part A, the x was given to me and I was supposed to find z. So I put it in the formula and found the z. In part B, the z is given to me and I'm going to find x. Can I use it? Can I still use the same formula? Yes. So we use the same formula, but this time we replace the z by 1.27 and trying to find x. Okay, if this equation is given to you and they ask you to find the x, what do we do? As a first step, to get rid of the denominator, we need to multiply both sides by 6.28. And after multiplying by 6.28, we need to move 170 to the right by adding 170. So that means x is equal to 1.27 times 6.28 and then added by 170. And the answer is 177.98. So if z is 1.27, the x must be 177.98 centimeters. Now it says this z-score, 1.27, tells you that the male's height is how many standard deviation? Z values are the number of standard deviation. So that means this z-score is 1.27 standard deviation And since the z-score is positive, we say it's to the right of, because positive z-values are on the right. And this is the formula that we use to transfer z to x. That's the same formula. If you remember, in this formula, which we had when we want converted x to z, if you want to find the x from this formula, to get rid of the denominator, you need to multiply both sides by sigma, which means x minus mu must be equal to z sigma. And now adding by mu to find the x, so which means x must be equal to mu plus z sigma. And that is, it's the same formula, just the way of writing is different. So you still can use the previous formula, or if you like, you can just write it in this form, which gives you faster way to find the answer. So remember, so far we learned if the x is given to me, I can convert it to z value. And if the z is given to me, I can also convert it to x value based on what question is asking and what I'm trying to find. Next example says, suppose that we have a random variable x, which is a normal distribution. The mean is 8 and the standard deviation 8 and the standard deviation is 1. It says what value of x? Okay, so find the x when the z-score is negative 2.25. Okay, so you can use either of those formula. It doesn't matter because they both represent the same formula, but just the way of writing. Okay, since you want to find x, you can use this one. Mu is 8, z is negative 2.25, sigma is 1, and now I can find x. But don't forget that in any mathematical operation, so we always follow PEMDAS, the order operation. And the PEMDAS tells me if there is any multiplication, I need to do the multiplication first. And add or subtract is for the second step. And 8 minus 2.25 is 5.75. Another example says a veterinarian records the weight of cats treated at a clinic. And the weights are normally distributed, okay, with the mean 9. The mean is 9. And the standard deviation is 2. Find the weight to find the x that corresponding to each of these z values. Okay, the z is given to you, you want to find the x, and you are going to use the mean and the standard deviation in your formula. So again, we're going to use this formula, replace the mean mu by 9, replace the sigma by 2, and the only thing that's different in each case, each part is the z value. If z value is 1.96 and replace z by 1.96, we get 12.92 pounds for x. If z is negative 0.44 and replace z by that number, we get 8.12 pounds for the x. And if z is 0 and replace z by 0, and 0 times 2 we know is 0, and 0 plus 9 is just 9 pounds. So the x must be 9. Okay, and we know when in any standard normal distribution, 0 is the mean. It's in the center of the bell shape, the bell curve. And that should be the same as the mean, which is 9. That's right. And now you can say that 12.92 is 1.96 standard deviation on the right of the mean. And 8.12 is negative 0.44 standard deviation away from the mean, which means 0.44 standard deviation on the left. Let's look at next example. He says, suppose that x is a random variable in a normal distribution. If the mean is 4, we know that the first number in a normal distribution is 4, and the second is the standard deviation, which is 2. Because what value of x is 2 standard deviation to the right of the mean? Find the x. When x is 2 standard deviation, okay, you know that the number of the standard deviations is the z value. When it says 2 standard deviation, that means z is 2. And when it says to the right, that means z is positive. So you're trying to find the x when z is positive 2. Okay, we use the formula. Mu is 4, z is positive 2, sigma is 2. 2 times 2 is 4, 4 plus 4 is 8. So the x must be 8. Now we have x, a random variable in another normal distribution, which the mean is 8 and the standard deviation is 9. Now it says what value of x is 0.67 standard deviation. So the numbers of the standard deviation is the z value. That means z is 0.67. But it says to the left of the mean. Left of the mean means negative. So this time z is negative 0.67, and now replace the formula by these numbers. So the mean is 8, the z is negative 0.67 times sigma, which is 9. And if I multiply 9 by negative 0.67 and then add it by 8, we get 1.96. In any normal distribution, when we have a bell-shaped curve, a symmetric bell curve, we can apply empirical rule. Empirical rule, which also called 68, 95, 99.7 rule, is a rule that only applies when we have a normal distribution. And it says when we have a normal distribution, that means when we have a bell curve, and you know in every bell-shaped curve, the mean is always in the center of the curve. It says about 68% of data lie within one standard deviation of the mean. That means if you have one standard deviation away from the mean, one standard deviation to the right, one to the left, 68% of data are in this area. If you keep adding by another standard deviation, this rule tells me 95% of data falls within 2 standard deviation. That means from this point to this point. And 99.7% of data lie within 3 standard deviation. And as you see, 99.7 is so close to 100. That means almost all of the numbers are within 3 standard deviation away from the mean. So that means the z value are from -3 to 3. So what does it mean? Because the numbers of the standard deviation is z value. When it says 99.7% of data are within 3 standard deviation away from the mean, that means only 0.07% of the data might not be in this area, which we usually call them unusual numbers. And anytime when we are finding z value, if we get any z value which is less than -3 or more than 3, that's a rare event that we get those numbers, and those numbers usually called outliers as well, which needs to be removed from the data set if we want to have a normal distribution. So 68% of data are in 1 standard deviation, 95% 2 standard deviation, and 99.7% of data are within 3 standard deviation away from the mean. Now, based on the empirical rule, we want to answer this question. So suppose X has a normal distribution with the mean of 25 and the standard deviation of 5. Between what value of X do 68% of the values lie? Okay, since we have a normal distribution, we have a bell-shaped curve, and the mean or 25 is in the middle of the curve. And if I keep adding by standard deviation on the right and on the left, I will get one standard deviation, two standard deviation, or three standard deviation away from the mean. So we always keep adding when we go to the right and keep subtracting when we go to the left. And this, my standard deviation is 5. And if I add 25 by 5, gives me 30. If I subtract by 5, we get 20 on the left. And the empirical rule tells me that the 68% of data are within one standard deviation. That means in this case, in this example, 68% of data are within 20 to 30. Because one standard deviation away from the mean means 20 to 30. Now it says about 95% of the X values lie between what values? Okay, based on empirical rule, 95% of the data are within two standard deviation. Okay, keep adding by one more standard deviation. That means keep adding by 5 on the right, which is 35. Keep subtracting by 5 on the left, which is 15. Now, based on empirical rule, I know that 95% of data are within these two values. That means 95% of data are within 15 to 35. So the only thing that you need to remember about the empirical rule, we always keep the mean in the center of the shade, and we just keep adding by sigma. When we go to the right, another sigma, and keep subtracting standard deviation from the mean when we go to the left. Okay. In section 6.2, now we want to use these properties of normal distribution to solve the problems and find the probabilities. How do you find probability when we have z-scores? So z-scores usually have a table, or there are different technology that can help you to use a z-score to find a probability. And I will show you on the paper right now, and in another video, I will show you how you can use the online calculators or TI-83 or 84 calculators to find a probability based on z values. But we strongly recommend using technology because the numbers on the table that I will show you might be some decimal off from the actual numbers that we get from technology. If you look at this table, it's called the z-score table. And in this table, the z values are given to you. Z values are adding these values to the left with the values on top. And the numbers in the body are the areas. Area under the curve or the probability. So if you are trying to find probability, you need to find the z-score and then look at the body to find the probability for that specific z value. This highlighted z value, as you see, is 1.1 plus 0.5, which is 1.15. So if the z value is 1.15, the probability or the area under the curve is this value. And you can see a complete table also in this slide. I just put the one picture of the negative z values, but we have another table for positive z values as well. So Z-value table are in 2 pages, one page for positive Z-values, one page for negative Z-values. So you try to find the Z-value by looking at the numbers on the left and on the top together, and then find the probability from the body of the table. All these numbers, decimal numbers, are the probabilities or the area under the curve. And something that it's important that you remember, when we have Z-table, the area under the curve is always the area to the left, as you see in this picture, okay? But if in any question you're trying to find the area to the right, you need to remember the number that you get from the table is area to the left. So what do we do to find the area to the right? Since the total area under the curve is always equal to 1, whatever number that we get for the area on the left, we subtract it from 1 to get the area to the right. Let's look at this example. It says find the area that corresponds to a z-score of 115. Okay, so if we have a normal distribution because we have z-value, and 1.15, z-value of 1.15 is over here. We want to find the area that corresponds to this z-value. We want to find this area, which means we need to look at the z-table. And if we look at the z-table, you see that 1.15, that means 1.1 on the left and 0.05 on the top, together gives you 1.15. And this number here, which is the intersection of these two values, called the area under the curve. So the area under the curve is 0.8749. But if you're using a TI-84 calculators, you can use this function, normal CDF. And since you want to find the area, and this area is all the area that is starting from the very left to 1.15, for showing very small number on the left, you always put negative 10,000, and you put the z-value that you have. And since the z-values are always for the standard normal distribution, and in a standard normal distribution, the mean is 0 and the standard deviation is 1. And these two numbers are the mean and the standard deviation. When you use this function, and you can find the area under the curve. Next example, find the area that corresponds with z-score of negative 0.24. Okay, this time I need to look at the negative part of the z-table. And negative 0.24, that means negative 0.24. And the total area, which is 0.4052. That's the total area under the curve. Let's look at this example. This time we want to find the area under the curve to the left of this z-value. Okay, so that means if we have a normal distribution and negative 0.99 is somewhere on the left side of the mean, you want to find area to the left. That means we're trying to find this area. Okay, when z-value is given to you, you need to look at the z-table or use the technology, as I said. But if I want to use the z-table, I need to find this number in the z-table. Negative 0.99 means negative 0.9 plus 9. So, and these two numbers are crossing each other at this point. That's the area under the curve. And we know that all the numbers in the z-table are area to the left. So that's my exact number. I don't have to change anything, because the numbers on the table are at areas to the left, and you are looking for the area to the left. So that means that's your final answer. So the total area is 0.1611. And it's better that if you have, if in any z-table you have more than 4 decimal digits, you always round it to 4 decimal digits. Next question says find the area to the right of this z-value. Okay. That means if we have a normal curve and the z-value is 1.06, I want the area to the right. I want this area. Okay, since z-value is 1.06, I'm going to still use this number as a z-value. 1.06. So 1.0 and 6. So these two gives me this number is 0.8554. But this number is the area to the left. But I want to find the area to the right. So what do? We subtract this number from 1. Because this number, 0.8554, that's the area to the left. But if you are looking for the area to the right, you need to subtract it from 1. And the answer is this answer is your final answer. That means your answer is 1 minus 0.8554, which is 0.1446. This is your final answer, not the answer from the table. And the next example is find the area under the curve between these two z-values. Okay, so if you have two z-value and you want to find the area between those two, so we have z equal negative 1.5, z equal 1.25, and I'm trying to find this area between these two values. So what do? We are still using the z-table. We need to use z-table 2 times, find the probability for each of these z-values, and then we need to subtract those values to get the answer. Because when you have the area for 1.25, the table gives you this area. When you find the area for negative 1.5, the table gives you this area. And if you subtract these two areas, you will get the exact area in between. And the answer is 0.8944, which is the number for 1.25, and 0.0668, which is the area for negative 1.5. And if I subtract these numbers, 8944 minus 0.668, and the final answer is 0.8276. That is the answer. That's the area between those two values. Next example, it says, we have a normal distribution. The x is a random variable in a normal distribution, which the mean is 6, and the standard deviation is 2. Find the probability that x is between 3 and 9. You want to find the probability when x is between 3 and 9. Okay, I'm only able to find the probability when I have z-scores, because the z-table gives me the probability, but I need the z-score to use that table. So what do? In this case, I don't have z, I have x values. Okay, and remember, anytime you have big numbers, those are x values, because z values are usually, numbers between negative 3 to 3 at most. So what do? We need to convert each of these values to find the z first. We need to see what z value, z is between what values. Again, we're going to use the same formula that we learned in this chapter. If x is 3, mean is 6, and the standard deviation is 2, we get the z value, which is negative 3 minus 6, which is negative 3 divided by 2, it's negative 1.5. So the first value is negative 1.5. And we need to convert the other one as well. Replace the x by 9. So 9 minus 6 divided by 2, which is 3 divided by 2 is positive 1.5. Okay, now it's time to use the z-table. We use z-table to find two numbers, one for area under the curve for 1.5, one time for finding the area under the curve for negative 1.5. And then we subtract these numbers. If I go to the previous example, I have the area for negative 1.5 here, which is 0.0668. I only need to find the area when z is positive 1.5. Let me just go back. 1.5, 1.50, it's here, which is 0.9332. 0.9332. And if I subtract these numbers, 0.9332 minus 0.0668, so the final answer, or the probability when x is between 3 and 9, is 0.8664. That's the final answer for this problem. Excuse me. Okay. Next example says the final exam score in a statistics class were normally distributed with a mean of 63 and a standard deviation of 5. Find the probability. Probability is the area under the curve. That means you need to find a number from the body of the table that a randomly selected student score more than 65. Okay, so that means you want to find the probability when x is more than 65. Okay, when you want to find the probability, as I said, you need z, not x. So what do? We convert x to z first. We need to find z. And see z is more than what number? And to convert that one, using the same formula, x is 65. That's your x value. Mean is 63, and the standard deviation is 5. 65 minus 63 is 2. 2 divided by 5 is 0.4. So the answer is 0.4. Now I can go back to the table, look at the z value of 0.4 and see what area do we get. So for 0.4, so let's see what we have here. 0.4. It's this number, which is 0.6554. Okay. 0.6554. But I know all of the numbers that I get from z-table are the area to the left. But now, when it says x is more than 65, in this problem, the mean is 63, and your x value is 65, and you're trying to find the probability when x is more than 65. That means you're trying to find the area to the right. But the number that you get from table, it's the area to the left. So what do? We subtract this number from 1. And the answer now is 1 minus 0.6554, which is 0.3446. And that's your final answer. Part B says find the probability that the randomly selected student scored less than 85. This time we want to find the probability when x is less than 85. If I want to show on a bell-shaped curve, I have a normal distribution. The mean is 63 and 85 is somewhere over here. And I want to find the probability, which means the area under the curve, when x is less than 85. Less than 85 means to the left side. Less than 85 means the left side of 85. Okay, again, we need to find z value first. Let's see what do we get for z. To find the z value, we use the formula again. The mean is still 63, the standard deviation is still 5. The only thing that's changed is the x value, which is 85. And 85 minus 63 divided by 5 gives me 4.4. That's one of the rare numbers. Now we want to find the probability when x is less than 4.4. And if I go back to the previous slide and look for 0.4, as you see in the positive z part of the z table, the greatest number that we have is 3.9, which means if you get any number more than that, you can just use the highest number in the table, which is 0.9999. So the answer for this one is also 0.999. And as you see, it's so close to 1. Okay, that means almost 100% of the students, score less than 85. Do I need to subtract from 1? No, because the z is less than means the left side, and I have the number from the left side, so I'm done. Only when we have more than, greater than, and I'm trying to find the area to the right, I will subtract the numbers from 1. Part C, it asks you to find the 90th percentile. We learned in previous chapters about the percentile. We said that the 90th percentile means a value that 90% of the data are less than that number. So that means if you have a bell-shaped curve again, the mean is 63, you're looking for a number. We don't know what number is, but something that we know that 90% of the data are less than that. That means this area is 90%. So this time in part A and B, the X was given to you. You see, the X was given to you, and they ask you to find the probability. That means find the area under the curve. But in part C, when they ask you to find 90th percentile, that means they give you the area under the curve, and now is asking to find the X. So what do we do now? We do the same. We are still using the Z table, but this time, instead of looking for Z value to find the probability, we look at the body of table to find the area and then see what Z value corresponds to that. I will stop this question right now, and I want to show you the next slide. So when we want to find the Z-score from the known areas, what do? We use the Z-score table, but looking at the body of the table. Let's look at this example. It says find the Z-score that 10.75% of the distribution's area it's right. So that means you want to find the Z value, which 10.75% of data are on the left side of that. Anytime you have percentage, that means you have the area. The area is given to you, but we always show the area as a decimal number, not the percentage. Even if you have the percentage, you need to change it to decimal, and the decimal means move the decimal digit to the left, which is 0.1075. That's the area. You look for this area in the body of the table and try to find the Z. Oh, to its right. Oh my God. I show to the left. So make sure that you don't make mistake like me. When it says the area to the right, that means that the right side must be, the area to the right must be 0.1075. Okay. If I go back to the table, this time I'm going to look at the body of the table, this body, and try to find that number, 0.1075. But something that I know about this table, that all numbers on this table are the area to the left. Is this area to the left or to the right? This is to the right. So what should we have to do? We have to find the area to the left first. How do you find the area to the left? Subtract this number from 1. And if I subtract this number from 1, we get this number, which means I am looking for this number on the table, 0.8925. And if I go back to the table and I see that 0.8925 is over here. And this number corresponds to what z-value? 1.24. So the z-score that has 10.75% of the area to its right is 1.24. Now we do the same on that example. Let's go back to this example. It says find the 90th percentile. That means find a number, find the x value, which 90% of the data are on the left. Okay. I'm not showing numbers by percentage. I always show numbers by decimal. So that means the area is 0.9. Okay. Now go back to the tables. Look for 0.90 on the body of the table. 0.90 usually must be on the positive side. And if I look at these numbers on the body, 0.90, or find a number that's closer to 0.90. You see these two? But I see that 0.90 is closer to this number than the other one. And this number is 1.28. Okay, so the z-value that corresponds to this number is 1.28. I'm using the same number because I have given the area to the left and I don't need to make any changes to that. Okay, but I get z-value. I'm not looking for z-value. I'm looking for the x value. I'm looking for the scores. Now I need to convert this one to x. And the x is equal to mean plus z times sigma, which the answer is 69.25. So if they ask you what's the 90th percentile, you say 69.25. 90th percentile, then we find the x value. Find the x value, that 90% of data are on the left side of that. That means that 90%, it's your area. So we have two cases. Sometimes they give you z value, you find the area. Sometimes the area is given to you and you find the z value. But anytime the x is given to you or they're asking to find, remember that you have one conversion as well, converting x to z first or z to x. So same here in this question, the area is given to you. That means you have the area and you want to find the z value. So just looking at the body of the table and see what z value corresponds to this. If the area that's given to you is on the left, you just look for this exact number on the table. But if the area to the right is given to you, make sure to subtract that from 1 first, and then whatever you get, you find that number on the table. So 1 minus 0.9265. So for in this case, you're looking for this number on the table. So make sure to find this one on the body of the table and see what z-value corresponds to that. In this case, again, the area to the right is given to you. Make sure to subtract it from 1 first, and whatever you get, look for that number. Next question is to find the z-score that corresponds to this percentile. P sub 5 means, or P5, it means the 5th percentile. That means you're looking for a number. You're looking for a z-value that 5% of data are on the left side of that. So that means the area to the left is given to you, and that area is 0.05. Looking at the body of the ZSD table, look for 0.05 and see what z-value corresponds to that. And you will see that the closest number that you get is, okay, we cannot find the exact 0.05, but you will see that these two numbers are close to 0.05, and they have the same distance to 0.05. Both of them are 5 away from that number. So what do we do in these cases? We find the average. What z-value correspond to this number? What z-value correspond to this number? Negative 1.64 and negative 1.65. Now we find the average of these two, or the halfway between negative 1.64 and negative 1.65, which is negative 1.645. Sometimes, if the exact number is not on the table, you choose the closest number. But if the closest numbers have the same distance, and you have more than one close number to that, you need to find the average of those two. When it says find the 50th percentile, that means find the value that 50% of data are to the left of that. Find a z-value that 50% of data are to the left. 50% of data means exactly in the middle of the curve. And we know that in any standard normal distribution, the mean is always in the middle. And the mean of any standard normal distribution is always 0. So the z-value that you get in this case is 0. Next example, it says height of men are normally distributed with the mean of 68.6. So the mean is 68.6 and the standard deviation of 3.8. Find the percentage of men who are taller than shower head at 72 inches. Taller than means more than. So you want to find the probability when x is more than 72. We have a normal distribution. The mean is 68.6. 72 is somewhere over here. And we want to find the probability when x is more than 72. That means we want to find the area to the right. Okay. To find the area to the right, I know any number that I get from table, I must subtract it from 1. But before doing find the number, I need to have the z-value, because right now I have the x value. And how do you find the z-value? By just using the formula for online calculators. So 72 minus 68.6 divided by 2.8. What z-value do we get? We get 1.21. So now I have the z-value. Z-value, it should be more than 1.21. That means you're trying to find the area to the right of 1.21. Look at the table. So on the table, on the left side, look for 1.2, and on the top, look for 0.01. And the number that you get for the area is 0.8869. But that's the area to the left. I know all the numbers from the table are the area to the left. I want area to the right, so I will subtract this number from 1. And the answer is 0.1131. And since it's asking find the percentage, I need to change this decimal number to percentage by moving the decimal digit to the right, 2 digits to the right, which means 11.31% of the men are taller than a shower head at 72 inches. And the last question, it says 2,000 students took an exam. The scores on the exam have an approximate normal distribution with a mean of 81 points and a standard deviation of 15 points. Find the first and third quartile. You know that the first quartile is Q1 and the third quartile is Q3. Okay. First quartile means find a number that 25% of numbers are less than that. So that means we want to find the 25th percentile. Third quartile means find a number that 75% of data are less than that. That means we're trying to find the 75th percentile. So to find the 25th percentile, that means you're looking for a number which 25% of data are on the left, showing in decimal. Okay, looking at Z table, the area is given to me, so I'm going to look at the body of the table, find 0.25, and see what Z value corresponds to that. And I will find that the Z value must be equal to negative 0.67. But this is a Z value. We're talking about the scores. The scores are X value. What do we do now? Convert it to X. So now I'm going to convert these to X by using the formulas that we had. And the mean is 81, Z is negative 0.67, and the standard deviation is 15. And the final answer for first quartile is 70.95. That's only the first quartile. We do the same for the third quartile. For third quartile, this time I'm looking for a number, a Z value, that 75% of data are below that number. This time the area under the curve is 0.75. So that means I'm looking at the body of table, look for 0.75. And then whatever we get for Z, we need to convert it to X again. And when it says in part B, when it's asking you the median 50% of the scores are between what two value, so you know when you have all of the numbers in order from the minimum to maximum, we said that we have three quartiles, first, second, and third quartiles, right? Each of these quartiles divide the whole data set into 25%. So 25% of data are here, 25% here, 25% on this side, and 25% on this side. When it says find the first quartile, that means the area under that is 25%. When it says find the third quartile, that means 75% or less than that. When it says find the median 50%, that means from this number to this number, because this is the median 50% of data. So the median 50% of data are between the first quartile and the third quartile. And right now, I have the answer for the first quartile, 70.95. And now you find the third quartile and see what number is the answer. So any number that you get for the third quartile, you can claim that the median 50% of the exam scores are between these two values.